Hello, I'm Michael Wunsch. I'm the plant pathologist at the North Dakota State University Carrington Research Extension Center. This is the first of a four-part series in which I'll be discussing the integrated management of Aphanomyces and Fusarium root rot in field peas. Now, this video is the long-form version of this discussion. I also have produced a video that gives an abbreviated discussion. In this video, the long-form version, I will discuss all of our major conclusions by giving full explanations. Now, first, I'd like to give thanks to the agencies that funded this research: the North Dakota Pulse Growers Association, the North Dakota Department of Agriculture's Pesticide Harmonization Registration Board, and the USDA Specialty Crop Block Grant Program administered by the North Dakota Department of Agriculture. These funding agencies made this research possible. I'd also like to give very sincere thanks to my very dedicated staff: Aaron Faust, Saran Collis, Jesse Hafner, Gabby Henson, and also our student workers. I'd also like to give thanks to the private companies that do contract fungicide testing with us. The proceeds from that contract fungicide testing are utilized to purchase the equipment, the farm equipment that we use to conduct our research studies. This research was conducted in Carrington in 2023 and 2024. All the studies were randomized with 6 experimental replicates. What this means is that the treatments were randomized 6 times. Okay. Plot size at planting was 5 foot by 30 foot. At harvest was about 5 foot by 20 feet. The reason why the harvest length is shorter than the planted length is because we assessed root rot in the first 5 foot of the plot and the last 5 foot of the plot. So we went into the first 5 foot and we dug roots to assess root rot, and we went to the last 5 foot of the plot to dig roots. And then after we dug the roots, we shortened the plots to exclude the areas where we dug roots. In this way, yield was always assessed from a section of the plot where no plants have been dug. We made every effort to assess root rot at a consistent growth stage across all planting dates and all field pea varieties, and we made every effort to assess the incidence of wilted plants, that type of wilt that's caused by severe root rot, at a consistent growth stage across all planting dates and field pea varieties. This slide shows the results from a very large study that we conducted evaluating 6 different field pea varieties across 4 planting dates with or without a fungicide seed treatment. The bar graphs show the yield response, and the numbers to the left of the bar graph show the percent of plants exhibiting wilt symptoms due to severe root rot at late pod fill. Now, late pod fill is the growth stage when the root rot is the most severe. What you'll notice immediately, if you look in the upper left-hand corner, is that we achieved in this study extraordinarily low incidence of wilt and very high yields with field pea variety selection, fungicide seed treatment, and early planting. Now, what do I mean by early planting? What matters is the soil temperature. In this case, the soil temperature was 45.2 degrees Fahrenheit on average, day and night, at the 2-inch seeding depth in the first 7 days after planting. Why do we use that metric of 7 days? That's because on warm, sunny days, the soil temperature is going to be warmer than on cold, cloudy days. And what really matters in terms of crop performance is the average soil temperature that the seeds are exposed to as they start the germination process. What we have found in our planting date research, which I will present in another video, is that you want to plant field peas between 43 and 50 degree Fahrenheit soils at seeding depth in these fields with elevated Aphanomyces and Fusarium root rot pressure. Now, why does this help with Aphanomyces and Fusarium root rot? It helps because Aphanomyces and Fusarium are favored by warm soils. When you plant into cooler soils, the field peas get a running start before the soil temperatures warm up enough for the pathogen to get very aggressive. So it gives the field peas a chance to get established and to start growing, and for their rhizobium to get established before the root rot starts to attack in any severe manner. So, with that early planting and field pea variety selection, we achieved excellent yields, very low end of season wilt. Anyone would be happy with that. Okay, and it's not because there wasn't root rot pressure. All you have to do is look at one of the other varieties towards the bottom that wasn't performing as well in the same planting date, or even worse, the next planting date, you can see that this field had catastrophic levels of disease pressure. And planting the wrong variety at the wrong time would lead to disastrous results. We ran the study a second time on a different field. This field also had severe Aphanomyces and Fusarium root rot pressure, and what you'll notice is that results are completely parallel. You needed to have that early planting and that proper field P variety selection and fungicide seed treatment to get optimal results. In this case, we ended up with field P yields of 65 to 69 bushels an acre and an end of season incidence of wilt of only 1 to 2% with that early planting, fungicide seed treatment, and judicious selection of varieties. So looking at those data another way, what I'm presenting now are results from the same two studies across the same 4 planting dates, but just with 3 of the 6 varieties. These are results of the performance of these varieties without a fungicide seed treatment. I will present information on the response to fungicide seed treatment in another presentation. In this case, we're looking at the varieties grown without a fungicide seed treatment. On the top, you'll see bar graphs showing the average performance in a given range of disease pressure. On the bottom, you see a scatter plot showing the yields obtained at different levels of disease pressure. What you can see immediately is that the relative performance of these varieties was consistent, just as I previously explained. You can see that in the scatter plot. You can see that in the bar graph. AAC Iron Horse performed better than Julius, and Julius performed better than Prophet at all levels of disease pressure. Those were the yield data. Now we're going to look at the wilt data. This is the percent of plants exhibiting wilt symptoms caused by severe root rot at late pod fill. What you'll notice is that there were huge differences in susceptibility to wilt across these 3 varieties. And the best variety was the best irrespective of the level of disease pressure. AAC Iron Horse developed dramatically lower levels of wilt than Prophet, and Julius was also much better than Prophet. So you would expect then that the root rot severity would differ, right? No, it did not. The root rot severity was virtually identical across all 3 varieties, irrespective of the level of disease pressure. So what this suggests is that what we were observing here are differences in the ability of the varieties to tolerate the root rot. They still get the disease, but some of the varieties are able to stay alive and not wilt as quickly, and are able to fill out their pods and produce yield, even though they're diseased. So let's look at that in greater detail. What were they tolerant to? Here are results from DNA-based diagnostic testing conducted on disease roots in those fields. And what you'll see immediately is that we detected very high levels of Aphanomyces and only low to moderate levels of Fusarium avenacum in these roots. We did not detect Fusarium excisperum at all. What this would suggest is that these field Ps had severe levels of Aphanomyces root rot, low to moderate levels of Fusarium root rot, and negligible levels of Fusarium excisperum wilt. Now, I say suggest because we did not test against the full range of Fusarium species that cause Fusarium root rot. There are other species as well, and we were only able to test against Fusarium avenacum. We don't know about the other species, but the symptomology is suggestive that Aphanomyces indeed was the predominant disease in these studies. Let's discuss the symptomology. First, let's look at the vascular necrosis in the epicaudal that is characteristic of Fusarium excisperum wilt. Fusarium excisperum wilt is different from the root rots in that varieties can be resistant, completely immune to specific strains of Fusarium excisperum wilt if they carry the right resistance gene. And thus, if you have specific strains of Fusarium excisperum wilt in your field, and you have a field P variety with resistance to those strains, it's going to develop less wilt than the susceptible one. Okay? And that could explain the differences in varieties that we just observed. But does it in this case? In this case, what we did was we looked at the incidence of the vascular necrosis characteristic of Fusarium excisperum in each of these varieties in the upper epicaudal, where those symptoms are generally the most severe. And what we saw is that the incidence of the vascular necrosis characteristic of Fusarium excisperum wilt was extremely low. And if anything, Julius was more susceptible than the other varieties. And thus, there's no way that Fusarium excisperum wilt would explain the differences in agronomic performance that we observed. Here's another way to look at that. We also took 1 centimeter long sections of epicaudal tissue that did not have excessive root rot on the outer surface, on the cortical tissues, and we put that onto microbiological media that is semi-selective for Fusarium, okay? i.e., it mostly only allows Fusarium to grow. Then we looked to see what percentage of those epicaudal sections had a fungal colony growing from the vascular tissues on the ends of the epicaudal sections. If Fusarium excisperum has colonized those vascular tissues, it'll grow out onto that microbiological media and produce this nice fan-shaped pattern. We saw this at only low incidence. And if anything, AAC Iron Horse, our best performing variety, was more susceptible. So again, these levels of incidence are not high enough to explain the levels of disease that we observed in this field. And they are also, the patterns here do not reflect what we saw for agronomic performance. And so what this means is that Fusarium excisperum wilt did not appear to be a significant contributor to the observed disease. What about Fusarium root rot? We evaluated the severity of the symptoms characteristic of Fusarium root rot. And what we saw was moderate severity. And if anything, Julius was more susceptible than some of the other varieties. Now, Julius, of course, was one of our better performing varieties agronomically. So what this would suggest is that Fusarium root rot was not the main driver, and differences in susceptibility to Fusarium root rot was not the main driver of the observed symptomology. Now, on that scatter plot on the right, you'll notice that the correlation and results in terms of Fusarium root rot severity across these two fields was almost perfect, which means that, again, these numbers were replicable. Okay, so moderate severity of root rot, and Julius being the more susceptible variety. We also scored the severity of symptoms characteristic of Aphanomyces, and what we saw is that the Aphanomyces severity was very high. This would correspond to the diagnostic testing. What it indicates is that Aphanomyces was the predominant disease, and Fusarium root rot was present, but was of more moderate severity. All right, so moving on. We did more testing of the impact of field pea variety selection. These are results from 2023, in which we conducted 11 planting date studies across fields differing in the interval since the last time field peas were grown. These are all fields with long history of field pea production and with Aphanomyces and Fusarium root rot present at various levels. What we saw here across these 11 studies and 4 planting dates is that Julius consistently yielded better than Prophet, irrespective of the level of disease pressure. And the yield gained at planting Julius versus Prophet got higher and higher as disease pressure got higher. And this is what you would expect with tolerance. As the disease pressure gets higher, the advantage to planting a more tolerant variety gets bigger. Similar results, or parallel results, were observed with the wilt symptoms. AAC Prophet developed much more severe wilt than AAC Julius at all levels of disease pressure. And so then you would expect this to translate into root rot, right? No. The two varieties exhibited very similar levels of root rot severity, If anything, Julius developed just a bit more root rot than Prophet. Okay, so what was underlying that? The diagnostic testing results are very similar to what we observed in the other two fields. What you see here, very clearly, irrespective of the levels of disease pressure, aphanomyces was the predominant disease. We detected aphanomyces at moderate to high levels in every field except for the two fields that had very low levels of disease severity. We detected Fusarium excisperam at low levels in a few fields, but only detected it from Julius, which was our better performing variety. So what this suggests is that what we were observing in these studies was that Julius was more tolerant to aphanomyces than Prophet. What about 2024? We did testing across 11 fields, 4 planting dates, just like in 2023. And if you look at the performance of Julius versus Prophet, you see the exact same pattern. Julius yielded better than Prophet at all levels of disease pressure. Julius developed less wilt than Prophet at all levels of disease pressure. Except in this case, notice we looked at the performance of these two varieties under catastrophic levels of wilt. Almost 100% incidence, okay? And when the disease pressure got to catastrophic levels, now the two varieties perform very similarly. What that means is that the tolerance to aphanomyces has its limits. When disease pressure gets bad enough, planting a tolerant variety isn't going to save you. Okay, you need to use other tools as well. This is just one of many tools. What about root rot severity? It's the exact same story we've seen all the way along. The Julius exhibits just a bit more root rot severity than the Prophet. It's negligible, it's a very tiny amount, but it's very consistent. And so again, the take-home story here is that we're dealing with differences in tolerance to root rot, not resistance. Here are the diagnostic testing results in 2024 across these 11 fields. We detected aphanomyces in every single field, and we detected at very high levels in all fields except for the two fields that had very, very low levels of disease severity. We did not detect Fusarium excisperam, which again re-emphasizes the point that the observed differences in field P agronomic performance cannot be explained by differences in susceptibility to Fusarium excisperam wilt. We did observe Fusarium avenaceum at low levels to moderate levels, depending on the field. And this emphasizes that Fusarium root rot did contribute. Now, I would have liked to have tested against the full range of Fusarium species, but this is all we were able to test against in 2024. You can assume that other Fusarium species also contributed. What about the performance of these varieties under very low levels of root rot pressure? Well, we tested the two varieties in Williston in fields with very low levels of root rot pressure in 2023. And what we saw is that the root rot severity, again, was virtually identical between the two varieties, and in this case at very low levels. And the yield potential of varieties, in this case, without much root rot pressure, was very, very similar. As the soil started to warm up and planting was delayed, then we saw a bit of an advantage to Julius, but otherwise the yield potential of the two varieties was virtually identical. And what about the pathogen pressure in those fields in Williston? Well, there was hardly any aphanomyces or Fusarium root rot pressure. We detected 0 aphanomyces, and we detected excisperam in only one of the two fields, and very similar levels across the two varieties. And we did not detect Fusarium avenaceum, i.e. root rot pressure in those fields was low. All right, and when root rot pressure was low, these two varieties performed very similarly, which again emphasizes the point that the reason why Julius was performing better than Prophet in the studies in Carrington was because it had better tolerance to root rot, not because it was intrinsically necessarily a better yielding variety. All right, so what have we learned? We have learned that there appear to be very strong differences in tolerance to aphanomyces and Fusarium root rot across field B varieties, particularly differences in tolerance to aphanomyces. Because of the studies that we have emphasized here had Aphanomyces as the primary root rot pathogen. Okay, and these results suggest that the use of field pea variety selection combined with early planting and fungicide seed treatment may be the tools that we need to achieve excellent agronomic performance in peas under severe Aphanomyces and Fusarium pressure. Now, the limitation of these studies is that they were all conducted in Carrington. At this point, I am 100% confident in the replicability of these results in Carrington. If we run these studies again in Carrington, I'm sure I'll see the exact same thing. What I don't know is whether or not we'll see the same results going on to other sites. The strains of Aphanomyces, the species of Fusarium, these differ field to field, and the relative importance of Aphanomyces versus Fusarium differs field to field. We need to do testing at on-farm sites before I can be confident that these results will be replicable across a broad geography and in your operation, in your farm. And so in 2025, we'll be doing that on-farm testing, and I look forward to updating you with the findings at the end of the 2025 growing season. Thank you very much for your time and attention, and thank you again, sincere thanks, to the funding agencies that made this possible. The Northern Pulse Growers Association, these are your checkoff dollars, and the North Dakota Department of Agriculture, and the two granting agencies that it oversees for this type of research, the Pesticide Harmonization and Registration Board and the USDA Specialty Crop Block Grant Program. Thank you for your time and attention, and thank you again to these funding sponsors.